Good morning. So the 12-factor app is a methodology for helping us build our applications such that they're more deployable or more easily deployable, and they scale a little bit better, and they're a little bit easier to maintain. Of you today, how many people are currently responsible for the deployment of one or more applications? How do those deployments make you feel? For some of us, these deployments are pretty easy breezy. Whether we have continuous deployment setup, or continuous delivery setup, or we have the ability to simply click a button and have our latest code base be pushed to production, we don't really have to worry about our deployments and whether or not we're going to break our live users at any given time. In a previous life, I personally was responsible for a Java-based application where I had to compile my jar, which would run on a Windows 2008 server. I had to SCP my jar over to the server, and then I had to make sure that all of my global packages and versions of Java were aligned across multiple environments just to make sure that this thing would work. And this would probably align me with somewhere between this hurts a little and this hurts even more. So I know that there are people out there that have much more grotesque horror stories than I do. And what the 12-factor app hopes to do is solve some of these problems. There are 4 guiding principles, the first of which is to use declarative formats for setup automation. So who here has ever started a new job, and you pull down the source code, and you pull up the environment setup guide, and you get about halfway through, and something is somehow broken? How fun is that? And this is really frustrating. Normally we're pulling over our new colleagues and we're trying to figure out whether it's something that we did, and we're trying to debug some code base that we're not entirely familiar with or at all. And we're trying to see whether or not it's us or it's the environment setup guide, which everyone knows comes out of date, and that's pretty much your first day on the job. Your job is to fix the environment setup guide for the next person that comes through the door. The second guideline is to have a clean contract between your application and the operating system that it's running upon. So as I said, in my former life, I was developing an application that would be deployed to a Windows 2008 server. Just this week, Microsoft announced that they were going to be sunsetting that, and I'm really, really thankful for that. But as a developer, I really don't want to worry about whether or not my application is going to run on a Linux machine that Amazon has created for me or some Windows environment that Microsoft's created. Really, I want to focus on the application itself and not whether or not the packages and dependencies that I need for my application to run are going to work on my host operating system. The third is to minimize the divergence between dev and production environments, in any environment for that matter. The reason we want to do this is twofold. One, it brings us one step closer to continuous deployment, in which we can continuously deliver our application to our end users without any fear of actually breaking them, and incrementally give them new features as time goes on. The second of which is that we want to avoid having any issues or minimize the number of issues we'll find when we have to reproduce a bug. So if we've ever had a bug that we've had to track down that's in production but not available in our development environment, that's an extremely frustrating experience when we can only replicate a bug in prod. By having parity between all of our environments, we can mitigate that risk, and we can hopefully reproduce these issues much quicker. And finally, we want to be able to scale our application. We don't want to have any significant changes to our development pipeline, our code, or the architecture of the application itself. The 12-factor methodology is encompassed, or these 4 principles are encompassed in these 12 factors. Today we have a limited amount of time, so we're only going to talk about a subset of them. However, I think these 4, configuration, build, release, run, disposability, and dev prod parity, are going to really showcase what these guidelines mean and how they can affect our applications. But before we get too deep into the weeds there, I want to talk a little bit about Docker. Docker is a company that provides containerization technologies, which allows us to wrap our application and all of its dependencies up into what we call a container, a single unit of deployment, and push that container to multiple environments. When I talk to new developers on my team who've never used Docker before, they typically ask, well, how do we create a container? What is a container? And a container really all starts with the Docker file. A Docker file is a text-based manifest that sits typically at the root of our project's directory. And what it does is it outlines a series of commands for running our application for us. I have a simple Docker file up here on the right, and it's got only 5 commands in it. The first uses Nginx and uses that as the baseline for our unit of deployment. So I'm going to use an Nginx server to serve my front-end application up. The second just labels me as the person to complain to when something goes wrong. The third, I copy my pre-built, my pre-bundled application. So I've already run Webpack, I've run Rollup. I've already taken my JavaScript and I've transpiled it if needed, and the output of that is in the build directory there. And all I'm doing is I'm copying that to a location that that Nginx can serve it up from. Next, I expose port 80, which allows me to communicate with my container. And then I run a command line instruction in order to invoke Nginx and to start it up. And there's this lineage between a Docker file to a container where there's this intermediary called an image. And what a Docker image is, it is almost like a cookie cutter that allows us to produce multiple containers. So I can create an image with my Docker file by running a command called docker build. And what I have up here is I am building my container with a tag called puzzle app, so that way I can easily find it later. And then I've got a period at the end here, and all that does is signify that I'm running this command in the root of my project's directory, and I can locate the Docker file needed to build the image in this directory from which I'm running the command. That Docker image itself can be shared with the community. There is a project, a series of repositories called Docker Hub, similar to GitHub. With GitHub, we push and pull code and projects. With Docker Hub, we push and pull images. So right now today, I can pull down maybe Nginx or a Redis image, and I can start using these things in a containerized context immediately. It's also worth noting that I can also share my Docker file itself. So we mentioned that it would be placed within the root of our project's directory. And what we typically want to do is check that into source control. And as a result, members of my team can pull down the project, and they've got the Docker file right there, and they can build their own image, which would be the same image that I would build with that same Docker file, and they can be off to the races running with their own container locally. And here I've got an example of how they might do that. I've got a command which is docker run. I signify my puzzle app as the tag that I want to use as the basis of my container. And with that, I can stamp out multiple in this context, puzzle-shaped cookies as my containers. And this is really powerful in that regardless of the machine that I'm running on and what my colleagues are running on, we can stand up the same application in any environment. And if we go and we look at the first guiding principle of the 12-factor app to use this declarative format in order to set up our automation, this is exactly what we're doing with the Docker file. We're declaratively saying, this is how I want to build my unit of deployment, and this is how I'm going to distribute it. And as a result, we fix all those environment setup guide woes in which hopefully we can say, go install Docker, go install npm, install Node, and you should be fine. So a second ago, I mentioned that any of my colleagues could be running my container on any environment. And what I really glossed over was the fact that they're all running on different operating systems. The power of Docker is that we can run our application really wherever. So in this case, I might be running on an OS X machine, Evie may be running on a Linux machine, and Tim might be running on a Windows machine. Regardless of our personal operating system of choice or whether or not our company decides to move over to some new vendor for producing laptops or giving us laptops, we can be fairly confident that our application is going to run wherever we need it to. And the way that this works is that there's this layer of abstraction between our computers, which contain some hardware, infrastructure, as well as the operating system, as well as the containers in which they're running. And that's the Docker engine. The Docker engine allows us to run our containers just about anywhere, and it's available now for Windows, Mac, Linux, pretty much anything that we would want to run our applications on. Again, if we revisit the 12 factor apps guiding principles, the second one was we wanted this clean contract between the underlying operating system and our application. And the power in this is, if we think about my conundrum in which I had to deploy to a Windows 2008 server, that's sunsetting in 2020 now. If I wanted to go and deploy that to an Amazon EC2 instance, I could do that had this application been containerized, and eventually we did containerize it. So this application can now safely move to another environment. So those were the first two guiding principles, and what I want to do now is I want to kind of look at a couple factors and see how they can contribute to the final two, which are minimizing the divergence between dev and prod and being able to scale our application. The first of which is configuration. The configuration factor states that resource handles credentials to external services, per deploy values, and the like are stored in an environment file rather than the code base itself. And you might ask yourself, well, why are we doing this? And there's a bit of a litmus test that we should ask ourselves. If our hosted code today were leaked, how many passwords, internal URLs, and anything that we would otherwise consider to be secret would be leaked? In order to externalize this, what we can do is create a .env file, and we can create these files for every single environment that we have. So I've got an example here in which I've created a .env file that is located at the root of my directory, or excuse me, my projects directory. And what I've done is I've created a rather verbose key-value pair. I'm working on a puppy app, it looks like. So we're going to hit omgpuppies.dev.foo. What we want to do is we want to create a .env file for every single environment that we have. And the reason for this is this allows us very granular control over the values that we're injecting into our application. One of the things that the 12-factor app states is that we really don't want to create what's considered to be a master.env file and then use some type of pseudo-inheritance in order to override them. That makes configuration really hard to track down when our application is actually live in production. So let's take a look at some code that might not be following the 12-factor app. So I've seen code exactly like this, where we have some means of inspecting what our current runtime environment is. And what we do is we basically switch off of that environment in order to get some value that we'll end up using in some way. So here we're keying off these environments in order to find the API endpoint that we want to hit. However, from a maintainability standpoint, this is kind of a nightmare, isn't it? So from a testing perspective, I've got to create a testing branch for every single one of these branches, every single if, else if. I've got to test all of those. If we ever add a new environment, so say we want to add local to this, I've got to find everywhere in my code base where I'm doing some switching, and I've got to add a new else if statement to say whether or not my environment is equal to local or not. And finally, if that top level domain changes, so let's say we've been developing with OMG puppies, but somebody grabbed that before us, we've got to go and change all of these URLs by hand and kind of retest all of our work. As a side note, I realized that .foo is actually going to be a real domain the other day, so that's coming. So rather than writing some code like this, where we have to do a lot of heavy testing and it's really not maintainable in the long run, what if we wrote something like this? All we have to do is have an environment-based file and have our build process inject that secret into our code base for us. It's much more maintainable in that I don't have to write a test for every single branching statement that I've got. I don't need to change the top level domain in every single file that uses it. And in all, this gets a lot easier to test. So the configuration step really leads into the next factor, which is build, release, run. And as the name suggests, a code base is configured or transformed into a runnable executable in 3 steps. We've got our build step, in which we take our raw JavaScript and we combine it all together and maybe do some transpilation and create what would otherwise be a runnable bundle. Release, wherein we combine that runnable bundle with our environment file in order to create something that will actually properly run with the correct values interpolated in it. And finally, the run step, where we actually invoke the process that's going to be running our application. So let's look at a case study of this. So Create React App is a project that's maintained by Facebook, who are also maintaining the React ecosystem. And they use Webpack for bundling the entire application. So as a part of going in and searching for all of the source files that are actually used within the context of your app, what it does is it amalgamates and combines all these files together until it's basically got one large blob of JavaScript. And what it'll do next is it actually uses a project called .env, which is typically used server-side. And what it will do is it will hunt down for all of your .env files, and it kind of follows, or it goes against this best practice a little bit, and then it kind of combines them and overrides your .env key value pairs. But what it'll do is it'll basically create an object for us that has all of our secrets and the keys associated with them. And what it'll do is it'll do that interpolation that we wanted to do for us. So what it'll do is if we have this really small get puppy details method, what it'll do is it'll signal on the process.env react puppy URL, and what it'll do is it'll automatically switch that over for us. And this ultimately leads us into dev and prod parity, which again, as the name suggests, between all of our environments, be it dev, stage, production, we really want parity amongst all of these. Similar to how all of my colleagues and I can be running the same container, we can apply that same principle to all of our remote environments. So I can build my application, my single app, theoretically for really any of my environments, and then combine the correct environment values that we want to inject into our application, and we can push that anywhere. So similar to how myself, Evie, and Tim were all running the same local build of our React puzzle app, what we can do is do the same thing for development and production, wherein we just push that same application, but slightly different values, such as URL handles and databases that we want to hit. And this is really powerful in that we have a certain degree of confidence, a high degree of confidence, that we know exactly what's deployed to our production environment at any given time. And we know that it's going to work because we've tested it. We've tested it in our dev environment, we've tested it in our test environment, and our staging environment. Similarly, if we're going to go about and we need to reproduce a bug in production, we don't have to worry about what dependencies are installed in which remote environment. In the past, I've looked at bugs and I've said, well, this remote server's got Java 8 underscore 162. Well, this one's got underscore 184, and what's the difference between them? This eliminates a lot of guesswork that we have to do in our application so that we can actually focus on finding what the actual issue is. And again, ultimately, one of the guiding principles of the 12-factor app was to minimize the divergence between dev and prod. And via configuration, via build, release, and run, and via the actual factor itself, that is dev prod parity, we're actually able to achieve this minimal divergence in order to hunt down bugs easier, in order to deploy and deliver features quicker. Next, I want to talk about disposability, which states that processes can be started or stopped at any given moment. So Docker containers by default are ephemeral in nature. So I can start them, I can stop them, I can destroy them, and bring them all back up again. As long as I've got that Docker file or I've got that Docker image from which I can base my containers, I can easily reproduce the image if I've only got the Docker file, and I can easily reproduce the container if I've got the Docker image. This is super powerful if we look at a real-world example in which we've got Nginx serving as a load balancer, and we've got traffic coming in, and we're just hammering our system. And over time, by no fault of our own, be it a network blip or whatnot, one of our nodes is eventually going to go bad, and it's probably going to fail a health check somewhere. It's unable to be contacted by some orchestration framework such as Kubernetes. Now, as a developer, I don't want to be responsible for making sure that that comes up, or I don't want to manually bring that back up. Rather, I really wish that somebody would do that for me. And in fact, with an orchestration framework, we can actually task this out, basically. So whether it be Amazon EC2 or Kubernetes, what have you, we can automatically bring our nodes back up, and we don't have to worry about it. Things can go off in the middle of the night, be down for a couple seconds, and have someone else bring it back up for us without us having to wake up or answer a pager call. Another point in which this is extremely valuable is testing. So in the event that you're running an application in which you need to do testing where the actions that you perform aren't necessarily idempotent, it can be a real pain when you're hitting a database and making sure that the state of your application, when you start your tests, in the middle of your tests, and at the end of your tests, that can be really hard and frustrating to maintain. And if your test should fail halfway through, you've got to reset this database, which is a real pain. Rather than worrying about maybe liquid-based migrations and resetting your database to some known state manually, what if we Dockerized all of this? So this extends beyond just a front-end application. Rather, I've got a React app, I've got Redis here, I've got a Java Spring app, and I've got a Postgres instance. What if I Dockerize all of these things? We can have them all communicate with each other, so why not bring them all down when we don't need them, or bring them down at the end of our tests after they've all passed, and then next time I want to rerun my tests, just bring them all up. Disposability is probably my favorite thing about this entire thing. The fact that I can just throw an entire environment away in the blink of an eye feels very Thanos-ish. So, in conclusion, today we talked about the 12-factor app. There are 4 guiding principles. We've got our ability to have this clean contract between our operating system and our application itself. And what that does is it allows for quite a bit of portability. We have the ability to automate our setup of the application itself via a very declarative format, which is our Docker file. We have the ability to minimize dev and prod and bring them into parity as much as possible. And we do this via our configuration and extracting that out. And we have our build, release, run step, wherein we combine our actual JavaScript with those environment files. And we've got our actual factor itself, which is dev prod parity, wherein we want to be able to find or minimize the number of bugs between dev and prod itself. And with disposability, we can scale up our application without any significant changes. So thank you all. You've been an awesome audience. I'm going to be posting slides to this later, or these slides later today, and I've got some just high-level resources for steering people in the right direction for 12-factor apps and Docker. Thank you.